In analyzing the evolution of blockchain usability, one of the primary challenges has been balancing decentralization, user privacy, and technical accessibility. The full node model, while integral to blockchain security and transparency, is impractical for the vast majority of end users, especially those operating on mobile platforms. Mobile wallets, in their pursuit of convenience, often encounter severe restrictions in CryptoNote-based blockchains, a problem that Beldex addresses through an innovative Masternode architecture. A traditional full node downloads and verifies the entire blockchain, which can be hundreds of gigabytes. This task is not suitable for devices with limited storage and bandwidth. Remote nodes mitigate this by acting as always online, full history servers that permit lightweight clients, such as mobile wallets, to query balances, scan for incoming transactions, or broadcast payments while holding only the keys, not the chain data. In ecosystems like Bitcoin and Ethereum, querying remote nodes is efficient. A user's public key serves as an account identifier, allowing for rapid searches within the ledger. Yet, most blockchains do not prioritize privacy to the extent that CryptoNote-based chains do. CryptoNote-based cryptocurrencies, such as Monero and Beldex, implement privacy technologies including stealth addresses, ring signatures, and one-time transaction keys. These methods ensure that external observers, and even block explorers, cannot trivially link inputs, outputs, or user balances. However, these features have a technical cost. Wallet synchronization and transaction detection require the private view key. This means the wallet must exhaustively scan potentially all blockchain outputs to recognize its incoming transactions. Consequently, mobile wallets depending on public remote nodes are compelled to download and scan large block sets, consuming significant remote node resources and resulting in overloaded or unreliable public endpoints. Additionally, node operators receive little incentive to serve anonymous users, and any misuse may further compromise privacy if connections are logged. The risk of IP address correlation presents a potential attack on user anonymity. Beldex approaches this predicament structurally. By mandating that every masternode also operates as a remote node, Beldex guarantees a distributed, stable, and privacy-respecting infrastructure. Masternodes in Beldex must meet high hardware and bandwidth standards, and their operation is ensured by a sizable financial stake. This requirement means operators have both the resources and economic motivation to keep a high-performance node online. The network, by default, becomes more robust, decentralized across varied jurisdictions and resistant to collusion due to the cost of controlling multiple masternodes. Operating as remote nodes, masternodes handle wallet requests without the constraints faced by voluntary or hobbyist operators, reducing the risk of downtime and increasing overall network reliability. Consider a user, Sarah, who accesses the Beldex mobile wallet. When she unlocks her wallet, her device automatically establishes a connection with the closest or most reliable masternode. This masternode facilitates blockchain scanning and transaction processing on her behalf, without demanding that Sarah's phone download or store the chain's full history. The economic disincentive for malicious actors, as running a masternode is resource-intensive and requires staking of funds, substantially lowers the threat of network-level surveillance. Moreover, with masternodes distributed globally, the potential for concentrated attacks or privacy breaches is significantly diminished. IP address exposure becomes less actionable when connections are routed through a large, diverse, and resilient node network. In summary, the Beldex Masternode model transforms a pain point, difficult, slow, and potentially insecure remote node connections, into a systemic strength. The dual mandate, serving as blockchain validators and as remote nodes, channels operate a profit motive into serving the network, fostering greater uptime and privacy for all users. From an architectural perspective, this model aligns economic incentives with network security and usability, positioning Beldex to offer superior privacy-protecting convenience for mainstream users. The approach marks a forward-looking solution as blockchains seek to expand their user bases beyond niche, technically skilled communities.